Here we're going to look at using graphing technology to solve equations. So using graphic technology to approximate the solutions of the equation, and they give us this equation of negative x squared plus 8x minus 13 equals the absolute value of x minus 4, and we're told to solve to the nearest tenth or approximate to the nearest tenth. The first thing I want to do, and I'm going to color code this, we're going to go to y equals, and I'm going to do the first one, the red one first. It's a little backwards, but that's okay. So we're going to type in negative x squared. You should be familiar with typing in equations by now. So if you're not, just look at one of the previous videos and that should catch you up pretty quickly. So we're going to type in y equals negative x squared plus 8x minus 13. I'm going to hit graph so I get an idea of what this graph might look like. It's going to be a parabola. It'll be reflected, or inverted, and it's going to be pretty much on the right side of my graph. So it's good to know where it'll be. And now I can plot the points. So we hit second and we go to table. You'll find that this method's pretty similar to what we've been doing, but our solutions, we're going to have to use the calculator to find them because they're not going to be as clear, but you'll see that in a second. So 0, negative 13 does not work for us. 1, negative 6 does not work. 2, negative 1, we can use that. So 2, negative 1, and then I'm just going to keep plotting these points here. 3, 2, 4, 3, 5, 2, so we've now found our vertex. 6, negative 1, and 6, negative 1, oops, 6, negative 1, and then 7 is off the graph. So I'll connect these dots, shape a parabola. It doesn't have to be perfect, and that's what our parabola will look like. Okay, so we have our first half of our graph. Again, the graph will look like that, which is what we have drawn, so that's good. All right, second part, we're going to go to y equals, and for y1, I'm going to type in that blue absolute value. So I'll just highlight this. I mean, it's color coded, but whatever. So this time, absolute value, you want to hit math, go to the number option and choose ABS. That's the absolute value, and we will type in x minus 4. We missed the subtraction sign, x minus 4. All right, so I hit graph, and I should have a graph that looks like this. So absolute value, which has been shifted to the right 4 places. So let's go to our table and pull some points. So we can go as far as negative 2. Negative 2, 6 works. Again, I'm not going to plot every single point here. I just need the shape of the graph. 0, 4. We'll go with 3, 1. 4, 0. That's an important point because that's where we're going to change directions. 5, 1. 6, 2. And then the furthest one, we can use 8, 4. And if you want to draw more points, feel free to, but we just need enough to shape our graph. So something like this. All right, now you've done this before. You found solutions using graphs, and your solutions were where they intersected, and it was the x values of those points. Well, the problem here is that those points fall between numbers. All right, they're not perfectly clear for us. So what we can do is we can use the graphing calculator to actually figure out what those exact solutions are, or at least an approximation. Right, maybe not exact. To do that, we're going to go back to the graph, and we know that we're going to have a solution. And just keep in mind that one of the solutions is going to be somewhere about here, and the other one should be somewhere about here. So maybe like 2.8 or 2.7, and something like 5.2 or 5.3. So that's just a range, or I shouldn't use the word range, kind of an area that we're looking for. So somewhere between 2 and 3, and somewhere between 5 and 6. So to find the solutions, you can use one of the trace features. So on the top right of your calculator next to graph, you have this trace button. So you can hit trace, and you can graph and kind of trace along here. Now, again, this will not be exact. So we kind of talked about that solution of being approximately 2.7. And then if we wanted to go over, we could find a solution that's approximately 5.3. Now, that trace isn't going to give us exact answers, and probably shouldn't be too reliant on it because we want to be as accurate as we can. So what we're going to do is you're going to hit the second key and then hit the trace button again, and that'll bring to calculate. We're looking for intersection points, so that pretty clearly means we should go to option number 5. Hit enter. And now it's going to ask for a first curve. What the first curve means is you're just trying to choose one of the functions, one of the graphs. So in this case, either the blue or the red one. Notice if I hit plus or up or down, it bounces back and forth between the red and the blue ones. And if I hit left and right, it scrolls along the blue one. If I change it to down and go to the red one, oh, it's not going to stop. And I scroll on there, it traces along the red one. The idea is you just need to pick one of them. It does not matter which. So first curve, I'm actually going to use the red one because that's the one we listed first. So it's just on the graph. As long as the cursor's on the graph or the function, hit enter. It's now going to ask you for second curve. Now notice that the blue one is kind of blinking there. If I hit down, it's going to go back to the red one, which is not what I want. I just need it to be on the blue one. So that's my second curve. You're choosing the other function. You hit enter. Now it's going to ask you to guess. We're not actually going to guess. What we're going to do is we're going to scroll to the right and put your cursor close to the intersection point, as close as possible. You'll hit enter. And now the graph or the calculator has looked at this graph and it's found that the intersection point is at 2.69 and 1.3. So those are the actual coordinate points. If you want to write those in on your graph, you could. So it's approximately 2.69 and 1.30, approximately. Okay. So it says to round to the nearest tenth, so that means my x value, I can say x is equal. Nope, not equal. I can say x is approximately 2.7. Now that's great, but that's only one of our solutions. We have 2 solutions. So we'll highlight that. That is one of them. You have a couple options. You can go right back to calculate. You can hit clear to make things go away. But what you're going to do is the same process, but with one slight difference. So hit second, trace. It'll bring you to the calculate screen. Scroll to number 5, because again, we're looking for the intersection point. It says first curve. Notice that it's kind of right on the red and the blue one. So we need to scroll over a little and make sure we're clearly on one of them. So that's the blue one. That's good enough for me. I'll hit enter. The cursor should jump to the red one. If it doesn't, just hit up or down and it'll jump to the red one. And choose your second curve, which is enter. Now it's going to ask you to guess again. The problem is if I put the cursor here, it's just going to give me the same answer that I already had. So this time I need to keep scrolling to the right and I need to put the cursor closer to my other solution. Whatever solution is closer to where you hit guess, that's the one that the calculator is going to give you. It's not going to pick them. It's not going to show you the second one unless you specifically kind of tell it to look for it. So put that cursor by the second solution, hit enter, and now we see that we have 5.3 and 1.3. So again, if you want to write that in, it's about 5.3, 1.3. We're going 1 decimal place, so a tenth. So we would say x is approximately 5.3. And that is our other solution. We can box those in if we'd like. And that's how you would find the approximate solutions using graphing technology. This becomes quite useful when your function, when the 2 pieces, the equations, they cross at somewhere that's not exactly kind of on the corner. So we can't use an integer. We're going to have to use some decimal points. You're not going to be able to look at it on your sketch and pull those points because our sketches are not going to be perfect. So don't rely just on your sketch. You do want to rely on the graphing calculator and make sure to use that intersect feature. All right, that's it for using graphing technology. You should have a pretty good idea now of solving equations and inequalities using the graphing calculators.